We're going to start talking about basic combinations today. And the reason is we have to learn this formula in order to do the binomial theorem, which we're doing next. But there's some probability and stats that are going to be on your test. So here we go. It says, oops, that's not supposed to be there. Permutations. One important application of the multiplication principle of counting is to count the number of ways that a set of objects, called an n set, can be arranged in order. Each such ordering is called a permutation of the set. Okay, before we learn much more about permutations and the formula for that, we have to learn about what factorial means. Anytime you have a number with an exclamation mark next to it, that is in math called a factorial. And it means to find the product of whatever that number is times the one less than that times 2 less than that all the way down until you get to 1. So for example, 5 factorial would equal 5 times 4 times 3 times 2 times 1. And if you did that math by hand, okay, you would have 5 times 4 is 20, 20 times 3 is 60, 60 times 2 is 120, 120 times 1 is 120. Or you can use the calculator. And to type factorial in a calculator, oh, by the way, 0 factorial is always 1. You just need to memorize that. Anytime you have 0 factorial, you can replace that with 1. Okay, but here's your calculator steps to find factorials. On your calculator screen, you type whatever number you're going to take the factorial of, hit your math key, arrow over to probability, and hit choose choice 4. That'll have the exclamation mark, and hit enter. So when I typed it in the calculator, I typed 5 and then I went to math prob 4. That put the exclamation mark, and enter gives me 120. You can type this on the calculator if you want to, but 0 factorial is 1, period. You just have to memorize that. Okay? 20 factorial, that's going to be 20 times 19 times 18 times 17 times 16 times 15 times 14 times 13 times 12 times 11 times 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. Now, I do not want to do that by hand, and I don't want to type all that in the calculator either. So again, if we use these steps and type it in the calculator, we get this big number. Now, what does this 2.4 something E18? What that means is 2.432902008 is that this decimal needs to move 18 places to the right. If it was E negative something, it would have to move to the left. So this big number is actually, this decimal moved 18 places. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. And you fill all of those in with zeros. And 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3. There's the actual number. I don't even know what that is. Okay? It's huge. Alright, so hit pause, do this one, preferably without the calculator. Hit pause, come back when you're ready. And you should get 24. This means 4 times 3 times 2 times 1. That's 12. Times 2 is 24. Times 1 is 24. Or your calculator. Alright, now this permutation thing that we were talking about in the beginning. The whole reason we had to learn the factorials is because you see that the formula has a couple of factorials in it. Alright, so it says the number of permutations of n objects taken r at a time, and that's the key. You have n total objects, but you're only going to take some of them. You're not taking all of them. You're just taking r of them at a time. It's denoted by this. You put the number of objects you have and how many of those objects you want to put in some sort of order, and that goes on the other side. And then the formula is how many ever objects you have, that's on top with a factorial. And then on bottom, you take the number of objects you have minus the number of objects you're trying to put in order, subtract those, and do a factorial on that number. And then divide, and you have your answer. Now, one thing that has to be very clear. If r is bigger than n, in other words, when you do this, normally the biggest number's on this side and the smaller number is on this side. If for some reason that's reversed and you're trying to take a permutation of a smaller number with a bigger one, it's not possible. For one thing, if you only have 3 objects total, you can't take 10 of them. It just doesn't even exist. It's 0. Okay? It ain't gonna happen. Alright, anyway, so look out for that. He'll try and trick you. Okay, now they're gonna want you to do some of this by hand, and I'll ask you to do a few by hand because I think it's important that you know the formula. But after we do a few by hand, your calculator steps to find n objects taken r at a time. The permutation is you type whatever number this is, the biggest numbers. You hit your math key, which is right here. You're going to arrow over. This screen will come up, but math will be black. So you're going to arrow over until probability is highlighted, and then these choices come up. And obviously you're going to choose number 2. So you hit your math key, arrow over to prob, hit 2, and that will bring up the right screen, and then you type your R value and hit enter. So here we go. Oh, darn it, that's not supposed to be there. Alright, by hand first, 6 objects taken 4 at a time. Alright, this says that you take the biggest number on top, that's 6 factorial. On bottom, you're going to take n minus r, so 6 minus 4, and take the factorial of that. That is going to be 6 factorial over 2 factorial. That is going to be 6 times 5 times 4 times 3 times 2 times 1. On bottom, 2 factorial is 2 times 1. Those 2's and 1's cancel out, and so my answer is 6 times 5 is 30, times 4 is 120, times 3 is 360. Or you can type it in the calculator. I typed the 5, then I did math, prob, choice, 2 I think it was, right? And then I typed my R, and I got my 360. Alright? So if we look at B, this would say 11 factorial over 11 minus 3 factorial. The top, that's going to be 11 factorial over 8 factorial. Now, this gets a little tedious writing it all out, especially when the numbers get big. This is going to be 11 times 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. On bottom is going to be 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. And all of those cancel out. And so what I'm left with is 11 times 10 times 9. Well, 11 times 10 is 110 times 9 is 990. Alright, if you type that in the calculator, 11 NPR 3, you get 990. What I was going to show you is when you have 11 on top and like the bigger numbers on top obviously and the smaller ones on bottom, you can actually kind of do this. Like I can go 11 times 10 times 9 times 8 factorial. I just don't want to finish that because I know on the bottom I have 8 factorial, which is going to cancel all that out. So again, when you notice that those are going to repeat, instead of writing it all out, just write the factorials and cancel that way. Alright, now when there's letters involved, we can't use the calculator because obviously we're not going to come up with a numerical answer. But if I simplify it as far as I can, this is going to be n factorial over n minus 3 factorial. And I can't simplify that because I don't know what n is. Now, I could, however... Yeah, no, never mind. Let's not go there. Alright, for D, okay, I noticed that, again, this number is supposed to be the biggest and this number is supposed to be the smallest. And it's not. When that happens, guarantee you, it can happen. If you only have 3 objects, you can't take 7 from it. Okay, so you can't do it, so it's 0. Alright, and if you type it in, you get the same thing. Alright, so you do this one, hit pause, come back when you're ready. And hopefully you got 20,160. This is going to be 8 factorial over 8 minus 6 factorial, which is 8 factorial over 2 factorial. which is 8 times 7 times 6 times 5 times 4 times 3 times 2 factorial over 2 factorial cancels. And my answer is 8 times 7 times 6 times 5 times 4 times 3 times, times 3, which is that. Or you can type it in the calculator. 8 NPR 6 is 20,160. Alright, so how do you simplify a factorial? You take the number times the number minus 1 times the number minus 2, all the way down until you get times 1. The permutation counting formula is n objects taken r at a time is n factorial over n minus r factorial. Okay? Alright, so the now we're going to get into some application problems of it. Okay, the formula isn't going to change, but what they're going to do is they're going to put words in it. They're going to say you're going to have this many objects, you need to take r of them at a time. How many ways can this happen? Okay, you're taking n objects, taking r at a time. You have n objects, taking r at a time. Okay, so it says 16 actors answer a casting call to try out for roles as dwarfs in a production of Snow White and the Seven Dwarfs. In how many different ways can the director cast the 7 roles? Think of this problem as you need to fill 7 roles and you have 16 actor choices. So again, if you think of it, you have n objects and you have to fill r blanks. I have 16 objects and I need to fill 7 roles. So again, that makes my n 16 and my r 7. So what I'm finding is 16 objects taken 7 at a time. So that would be 16 factorial over 16 minus 7 factorial. That would be 16 factorial over 9 factorial. That would be 16 times 15 times 14 times 13 times 12 times 11 times 10 times 9 factorial. I'm not going to keep going because I know on the bottom I have 9 factorial. So the 9s, 8s, 7s, 6s, 5s, 4s, 3s, 2s, and 1s will all cancel. And that product on top is my solution. And again, I would just use a calculator. I mean, you could just type 16 times 15 times 14 times. Again, I'd like you to write the formula out, but then I don't mind if you actually get the computation using the calculator, because this is what's most important, is that you understand where the numbers go and what it means. So this is what I would prefer for you to show work and then type it in the calculator. You type 16 NPR 7 and you get 5765760. So there are 57,657,600 possible castings for the 7 dwarfs. And that's just if you only have 16 choices. Okay? Alright, so you try this one. Hit pause. Come back when you're ready. And hopefully you got number 1, 3,628,800. Alright, a baseball manager has 10 players of the same ability. Okay? How many 9-player starting lineups can he create? So, he has 10 objects and he's taking 9 at a time. So that gives me 10 factorial on top over 10 minus 9 factorial on the bottom. That's 10 factorial over 1 factorial, which is 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. 1 factorial is 1. Those are the only thing that cancels. Multiply all those numbers out or type it in the calculator and you get the 3,628,800. Yeah? Okay. So try this one. Hit pause. Come back when you're ready. And hopefully you got number 1. If you didn't, let's look at why. You have this word payment, which has 1, 2, 3, 4, 5, 6, 7 letters in it. So you have 7 objects, and you want to take 5 at a time. So we're finding 7p5, which would be 7 factorial over 7 minus 5 factorial, which is 7 times 6 times 5, which is 7 factorial over 2 factorial, which is 7 times 6 times 5 times 4 times 3 times 2 factorial over 2 factorial. Those cancel, multiply those out, or type it in the calculator, and you get 2,520. Alright, do this one, hit pause, come back when you're ready, and hopefully you got 210. You are placing 3 flags, but you have 7 to choose from. So you have 7 objects that you're going to take 3 at a time and put on the pole. By the way, in all of these examples, the order that these things happen in matter. We have a completely different formula when the order of the objects that you're taking doesn't matter. These matter. I mean, what order you put the flags in on the pole, if we care, then we use permutations. If we didn't care, then we would use a combination instead, which we're going to get to in a second. But right now, I care about the order that the flags go in. So I'm using a permutation. So that would be 7 factorial over 7 minus 3 factorial, which is 7 times 6 times 5. I keep forgetting to do that second step. 7 factorial over 4 factorial, which is 7 times 6 times 5 times. I can stop at 4 factorial because I know that's what's on the bottom and they cancel. So 7 times 6 times 5 is 210. Or you can type it in and get the right answer. Alright, go do this one. Hit pause, come back when you're ready. And hopefully you got 10,626. Alright, we are taking 3 numbers from a total of 23. So we have 23 possibilities, and we're ordering them 3 at a time. But the order that the numbers happen in matter. So this would be 23 factorial over 23 minus 3 factorial, which would be 23 factorial over 20 factorial, which is 23 times 22 times 21 times 20 factorial. I can stop there because I know that's on the bottom and going to cancel. So that product is my answer. Either type that in or type the permutation in, and you get the 10,626. Alright, so we already answered that. The combination counting formula. Now this is when the order that you put things in does not matter. Okay, the formula looks pretty similar. The only difference is you're still taking n objects r at a time. Okay, but now the order that the objects you're taking in, when the order that you take them doesn't matter, you use the combination formula instead of the permutation formula. And it's got one extra little thing to it. If you take that r away, that's the permutation formula. You add this extra r factorial in there, and now you have the combination formula, and that's because the order doesn't matter. There's going to be more possibilities. Okay, and again, this number is the bigger one. This number is the smaller one. If it's reversed, then the combination doesn't exist and it's 0. Okay, to get it on the calculator, the factorial stuff is the same. It's the same calculator steps, except for instead of hitting math prob 2, you're going to hit math prob 3. Permutation is 2, combination is 3. Alright, so for the Miss America pageant, 51 contestants must be narrowed down to 10 finalists who will compete on national television. In how many possible ways can the 10 finalists be selected? Right now, I don't care about the order. I'm not picking first place, second place, third place. So I'm just picking the 10 that the order doesn't matter in. Okay? So because if the order mattered and I was picking first through 10th place, then I would have to do a permutation. But right now, I don't care who's number 1, number 2 to 10. I just need the 10. So I have 51 objects that I'm going to take 10 at a time, but the order matters, so I'm doing a combination formula instead of a permutation. So you put 51 factorial on top, r factorial on the bottom, and then n minus r factorial on the bottom. So this is going to be 51 factorial over 10 factorial times 41 factorial. Okay, and then if I write this out, this is going to be a huge pain. Alright, I'm going to have 51 times 50 times 49 times 48 times 47 times 46 times 45 times 44 times 43 times 42 times 41 factorial. I know I can stop there because this 41 factorial is going to cancel it out. On the bottom, I'm going to have 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1 times 41 factorial. The 41 factorials are going to cancel out. Alright, and then you'd have to do this math on top. You would type all of that in parentheses divided by all of that in parentheses. And I don't really want to do that. So again, if we use our calculator, I type the 51, then do math, prob, 3? Alright, and then I type the 10 in, and I get this number, which is 1.27777, 1187. This E10 means this decimal is 10 places to the right. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Fill in the zeros, and that's my number. Huge. Alright. Go. Hit pause. Come back when you're ready. And hopefully you got 364. You have 14 people in a club. You're choosing 3 of them at a time to represent the club at conference. Again, the order does not matter. It's not like you're picking a president, a secretary, and a treasurer or something. If that mattered, you do a permutation instead. But I don't care. I'm just picking 3 people to go to this conference. They don't really have titles or anything, so the order doesn't matter. So I have 14 objects that I'm going to count 3 at a time. The order 3 at a time. So that's going to be 14 factorial over 3 factorial times 14 minus 3 factorial. So that's going to be 14 factorial over 3 factorial times 11 factorial. So on top I got to go to at least 11. 14 times 13 times 12 times 11 factorial over 3 times 2 times 1 times 11 factorial. Those cancel, so I have this divided by this, which is 364. Or you can type it in the calculator and get the same thing. Again, I want to see that you write it out, but after this point, yeah, type it in the calculator. Okay, hit pause, come back when you're ready. And hopefully you got 715. If not, you're choosing 9 numbers out of 1 through 13. That's 13 total objects that I'm ordering 9 at a time. But I don't care in how many ways can this be done. It doesn't say that the order matters. Okay? So that would be 13 factorial over 9 factorial times 13 minus 9 factorial. That would be 13 factorial over 9 factorial times 4 factorial. And again, the biggest one on bottom is a 9, so I'm going to have to go 13 times 12 times 11 times 10 times 9 factorial over 9 factorial times 4 times 3 times 2 times 1. The 9 factorials would cancel, and I would have this divided by this. And you could type it that way, or just type in the NCR, and you get the 715. Alright, you try this one, come back when you're ready. Alright, there are 13 essay questions that kids can select 3 from. So you have 13 total questions, and you're taking 3 of those. It doesn't matter what 3, it doesn't matter what order, so it's a combination, not a permutation. And that is going to be 13 factorial over 3 factorial times 13 minus 3 factorial, which is going to be 13 factorial over 3 factorial times 10 factorial. So I have 13 times 12 times 11 times 10 factorial over 3 times 2 times 1 times 10 factorial. Those cancel, so it's this divided by that, which is 286. Yours, type it in and you get the same answer. Alright, so what is the combination counting formula? That's when you have NCR, which is n factorial, over r factorial, times n minus r factorial. Again, order matters on permutations. Order does not matter on combinations. Okay, and we are at homework, so we are done. Happy homeworking, and I will see you next time.